current, resistance, and what is electromotive force?
Voltage.
Voltage in series and also in parallel. And we'll talk about it now. We'll do some practices numerically, and then we'll go to the lab and do it practically. So you can see how this is very important. And now everybody knows how to use continuity, how to measure voltage, amperage, and resistance. If you feel confused, you forget, that's okay. We will keep doing this over and over again, but these are the basic needs we need for electrical circuit. These are some of the terms. Well, what did closed mean? It's off.
It's connected.
There's nowhere for it to go?
Yeah, there's complete circuit, there's no opening in it. Control circuit. What is control circuit?
Stable?
We try to control things on and off. Circuit, sub-circuit. If I want to control the AC, I'm going to use a thermostat. That's a control circuit. If I want to set the temperature, I'm controlling the AC. Electric circuit, a complete path, complete path. Open is incomplete path. There is discontinuation. Parallel circuit goes next to each other. So when we say parallel, usually in math, we mean two lines next to each other are not touching. Correct?
Yeah.
It's not the same analogy here. They're still not touching, they're still going next to each other, but they don't have to be looking like this. This is parallel, right?
Yeah.
So this could be a little bit confusing.
Yeah.
They can go this way as well. They're not touching, they are divided. So the current going here will go up this way, and those two are in parallel. Or it goes this way, and this way. So basically they branch, they divide, they split. Split, divide, that is parallel circuit. Meaning, the incoming current equals the sum of those currents. Series circuit, loads go one after another. Bless you. So the same current goes over each one of those resistances. What about series and parallel circuit? You're gonna have a combination. You're gonna have so these two are in series, and these two are no, these with each other. Three and four?
Those two are in series.
Yeah. What about those 1 and 2 and 3 and 4?
Parallel.
1 and 2 are in parallel with 3 and 4.
Yeah.
Everybody see that?
Yeah.
So it's kind of like they're in series but parallel.
So this is a combination circuit now. This is parallel, series, combination. We'll talk also about voltage drop. So if voltage is our force, is our potential, our pressure, eventually it will drop. If you have faucets in the same pipe, which one will have the most pressure? The first one. When it drops, it drops, it drops, until eventually the last one has no pressure at all. So things in series, always you have a drop. Same thing with series circuit. This one will get 110 volts. This will drop. We'll get something less than that, 80 volts. It's going to be 40 volts. Depends. That's how the same is. You can think about how in the beginning this will eat some of that pressure. A little bit more, a little bit more.
Is that the parallel?
This is confusing a little bit. We'll do some examples to make it really, less confusing. So we have for any electrical system or any equipment, there's always a combination. We have both. We have series and we have parallel. Again, parallel circuit, more than one path. Series circuit, only one path. Let's write it down. One path for what? For the current. This is the example. What are those squiggly lines? This is current. R1, R2, R3, and this is the current. I'm gonna put A. Current is, so the current here is the same as the current here, same as the current here, and current is the flow going through that circuit. For parallel, so this is the current coming here. However, it's dividing. R1, R2, I'm gonna call this A1, it's gonna be A2, A3. So if I add A1 and A3, what would I get? Benny?
A5.
A1.
If I add those two. Now I'm gonna get A1, because this has divided. So if, for example, this is 3, and this is 2, what would that be?
5.
Why 5?
No, 1.
Yeah, 1. So I'm going to make this less confusing. So this is parallel, more than one path. Good. Why do you think we need to use series circuit? This other reason to use it. Control. If I want to turn something on and off, if I have a switch here, this is off, nothing will go through. So it's mostly for control. Controlling something on and off, switches. Second thing, when we did the wiring in the board, what was the first thing coming out of the plug? What was the first thing right out of the plug?
Switch.
No, the first thing.
Name.
Fuse.
You have to got the
Fuse or circuit breaker. Then we got switch. Then we got a firematic, right?
Another switch.
Yeah, so what are those for? Yes.
Detecting heat.
Safety. So safety. Why is that? Because if the fuse blows, the whole thing will go out, right?
Yeah.
If the circuit breaker trips, there's no circuit. If the firematic switch trip, there's no circuit. So whenever you want to design for control or safety, you use series circuit. I'll say it again. If you're trying to have control over the thing on and off, like if you want to control this light bulb, I'm not going to wire the switch in series. I'm going to wire it. I mean, in parallel. I'm going to wire it in series. So on, off, on. That's control. Okay. What about safety? Circuit breaker is wired and on series. If the fuse breaks, everything shuts off. So safety and control, that is series circuit. Question, confusion, Benny? Make sense? Control, safety, in series. You drive your car, turn on and off the AC, that's in series. If the fuse goes out, the whole thing goes out. The whole circuit goes out. So, what about in parallel? If this, I'm gonna continue the circuit here. Over to the source. So what about in parallel? What happens if this burns out? Do I have an open or complete circuit?
It's still complete, sir.
Still complete circuit.
Oh, yeah, because you have the other.
Yeah.
Okay.
So you can blow one of those lights and it's still going to work. So if I put a switch here, it's not going to do anything. Whether it's on or off, there's another path. And current always follow the path. So what do you think we use the parallel circuit for?
Power more.
Okay, more loads, redundancy. So if I have 3 lights in series, if one of them goes out,
You still have two.
it's not 2. What about the Christmas light thing? Remember when one of the light goes out, the whole system goes out. So you don't want wire loads in series. You want it to be in parallel. So more loads. So every load will get a current. Okay, what else? Another advantage that we'll learn about now. Voltage will always become the same. So the current divide, the voltage is going to be the same. So if you wire this is in series, we think this one gonna get all the voltage, less voltage. Probably by here, there's no voltage at all. This current, there's no voltage. Over here, they get the same voltage. So if I go to these receptacles here, we have 3 or 4 of them. Every one I go on this, what should I get? 120,
Yeah.
because they are wired
Yeah.
in parallel. So it's the advantage of when I have loads, I want loads to be in parallel, and I want control and safety to be in series. What do you think about that? So far, it's okay. You will keep it so you can remember. I know in the beginning it's hard to register and hard to remember all these things, but with practice, they will become more of a second nature. So we need a complete path. We talked about closed circuit. We talked about open circuit. There's path, no path. And if I want to remember, how do I distinguish a circuit that is in parallel or in series? It's always good to look at the current. If the current is the same, then it's a series circuit. If the current divide or split,
That's parallel.
it's a parallel circuit. So this is a good way to look at it. Again, they're not going to look this way. It's not going to look as simple as this on paper. In reality, you'll see the wire goes and it forks, and you're gonna put a pigtail in it, 3, 4, 5 loads, and the other split more and more. So the key thing to remember is if you split the current, it's parallel. If the current is the same wire, then it's in series. So we need a complete path all the time. Source electron flow, some load, because there's gonna be a load, otherwise what's the point of the circuit? So who last week when we did the lab didn't have a circuit running because of the neutral? So everything was running okay, but the neutral did not connect very well, and that means there is no complete path. Nothing will go. There is no flow. No flow, no current, no circuit. Even though there's voltage, if I have a break in the circuit here, when wire was cut, I will go and measure the voltage here. There's voltage, but there is no current. I'll be voltage all the way here, but if I do a continuity check, from here to here, I'll be okay. Then from here to here, I'll find there is missing part. So these are some of the basic concepts about circuit. Okay, so we need to have, this is load, plugs 120 volts, load, and a complete path. Series circuit is very simple. So when we did, remember we put the switches all in which wire? The hot or neutral? Huh? Yeah. It was the black line. So all the loads were, all the switches were in the hot line. The neutral was coming from the end, just to complete the circuit. So it's very simple, it's very easy. You go through switches or controls one after the other, and the neutral comes all the way from the back. Control, we did control with the switches, we did safety with also safety switches. So this is the way we do it, it's control and safety, and that is the series circuit. Now, is this in series or parallel?
Series.
Why are you answering in the form of a question? Yeah. Don't have doubts.
So there's one path.
Yeah, it's in series. So the current goes here, 1, 2, 3. If they are one after another, they are in series. What about, is this motor in series or in parallel with these?
Series.
The motor is in series.
Yeah. Why? It's the same path. Follow the path. What is L1? Hot wire. Power. L2?
Common, neutral.
Common or neutral? Yeah. So it's gonna go all the way around and go here. So this is a series circuit. 3 switches controlling electrical motor. Questions? Doubts? Confusion? One path, 3 switches, 1 motor. Series. Okay, here is when it gets a little bit interesting. Don't look at that. Take a look here.
Kill me for that.
So if this is, what is the unit of resistance? A.
Sorry?
What is the unit for resistance?
Ohms.
Ohms, okay. Great. 1 ohm, 2 ohm, and 1 ohm again. If I would like to measure the total of these resistors, so if they are one after another, what would that be?
Just add them.
I want to add them all together. I want to find the resistance. If I put my ohm meter here, I'll find, what is the reading?
1,
1. What about here?
3,
3, 4. It's because they are right after another, and I'm gonna have you test that. So the resistance total equal R1 plus R2 plus R3. You agree?
Yeah.
Got it? Simple. And you can go and test it. Take the ohmmeter, it's gonna be the total resistance. If this one is burnt, and I put the ohmmeter here, what would I get?
2.
4.
This is burnt.
Oh,
0.
current.
What would I get for resistance? What was that 0? It is 0. There's no resistance. It's incomplete
Oh,
circuit.
yeah. Okay.
So this is how you know if these are serious, that is,
So
this
if
is,
one of the circuits is burned out, it's gonna be 0.
yeah, no continuity. Good? Okay, how about the current? The current goes from here, comes out, goes in here, comes out, and goes all the way back. So what is the current? What's the current? If I clip on here, I'll get a number. What if I clip on here?
You get a number?
Yeah, is it gonna be the same, bigger or smaller? Current.
Alright.
I'm talking about current now. Flow. So when we clipped the ohmmeter on the black wire, what was it? 0.5, right? When we put it in the white wire, what do we get?
0.
Because when you do both.
No, remember, clip the ammeter on the black wire. Then I clip it on the white wire. What was the number? Were they the same? Were they different?
Do you mean with the both of them
Yeah.
on? That's
No, not
zero.
both, one of them.
Oh.
They were the same.
Each, they were the same. If you remember, it was the same, right?
Yeah.
And we did both, it was 0. So current is going to be the same. We have the same. Questions, doubts, confusion?
So the current is gonna be the same,
Yeah.
no matter where you put it.
If it's in series, it's going to be the same. So the one light bulb, we put the clip on in the black wire, and the hot wire was 0.05. Put it in the white wire, it was 0.05. It was the same. If you recall, we did that. Okay, the other part, which is new now, is the voltage. What do you think will happen to the voltage?
Drop.
Think of the water faucet and the water flow.
So the voltage.
It'll go down.
Yeah, it will drop. So this will eat most of the voltage. It will use whatever voltage it needs. Then it will drop and drop. So if I have light bulbs, it's going to be very bright. So it'll be dimmer,
Okay.
dimmer, dimmer, dies off. So voltage will drop. So what is the voltage between here and here?
You said it was 120?
Yep, it's gonna be 120, but not each one of those light bulbs or resistors get the 120. First one, eat all of it,
Will it go down by a certain amount, or will?
depending on the load. Every load will take whatever it wants, like the faucets, think of the faucets again. First faucet will get the entire pressure, second one, depends, it's gonna be lower pressure. If you close the first one, the second one will get most of it. So think of water flow and leaks. So resistance will add up, current is the same, voltage will drop.
For a series circuit.
Yeah.
It's kinda like when someone's in the shower, you don't wanna push it.
Exactly, because then you're right. Because all the water gonna go to fill the toilet tank, and you get only hot water and it's cold. That's if you wire all those things in series, which usually they are for hot and cold water. So same thing. Good? Don't change it, I'll come back. So that's what I'm trying to say here. Current will stay the same. Resistance will add up. That's what it says here, and that's in series. So, would I want to wire loads in series?
No.
No. Why? Because again, they're not going to get the same voltage, they're not going to run properly, and the first one will run okay, the second one will not run okay, and so you might see this sometimes. Somebody will, by mistake, will wire things in series and in parallel. What about the voltage? You say the voltage will add up. So all this verbiage mean that the voltage will drop. Think of the water faucet. First one will get all the voltage, second one will get the remaining, and probably it will decrease. Don't worry about that. Okay, we're good? I'm going to repeat all this on Wednesday. Yes, sir. Huh?
Oh, repeat it all. Okay.
So I want you to remember that because it's very important. I'll use some examples as well. What about those two loads? I mean, this voltage. What are these loads? Are they in series or parallel? Is it the same path? No. I'm gonna go here and this is gonna split. Then it splits some more, and it splits some more, and comes back, split the last voltage, then it will add up, and add up, and comes back here. So the voltage between those two lines are going to be the same, 120, but the current has been split. The flow has been split to each one of them. If this one light goes out, the system will still run. If the compressor goes out, the fan will still run. Because we still have complete circuit. So this system is in parallel. Yeah. So each one will run individually. So what do you think will happen to the voltage?
Voltage will
Stay the same.
No.
Remain the same.
Yeah. Voltage will remain the same. So voltage will remain the same. What about the current?
It'll increase
Huh?
to each one.
Yeah. It will split, right? It will divide. So it will divide. So A total will equal A1 plus A2 plus A3, etc. Because if this is A1 coming inside, This is the first current. You're gonna lose some part of the current. All of it here, all of it here. But at the end, they will add up and become the same here. So the current coming in is the same as the current coming out. You agree? So it will be the total. So the tricky part now is, and the very interesting one is the resistance. What do you think will happen to the resistance?
It will decrease.
Yes?
It becomes
Resistance.
the average.
Professor, what's the last thing that's right there? At the end, A total equals A1 plus A2 plus.
A3.
One place to divide.
Yeah, you add them up and divide.
So
Try to do
it
that.
will divide, it means like it will split. Let's say split. It's easier, split. Let's put split.
SPL.
Yeah.
It will split. Yeah.
So it'll split to each one and then add.
Yeah, yes.
And then R equals D.
Resistance will decrease. That's the tricky part that the limit.
Yeah, because you have more loads.
Yeah, but when you add it together, it's going to be a very small resistance. And here is another interesting part. I'm gonna put it here. Decrease. So R, this is too small. R total equal smaller than the smallest resistance in the parallel circuit. So if this is 1 and this is 2, what do I expect the resistance to be? If it's gonna be smaller than the smallest one.
1.
So it's smaller. It's gonna be smaller than 1. We don't know, 0.5, 0.3,
Just
0.5.
smaller.
It's gonna be smaller. So if you do the math and you get something bigger than the smallest one, you did something wrong. And I will go through the interesting math here. We'll have that when this is in parallel. Yeah.
I have a question.
Yeah.
So, what kind of circuit is needed for a giant generator to power the entire city?
You're always gonna have combinations. Always combination. You're gonna have wire controls and safety in series, then you're gonna wire your loads in parallel. Good? And we will remember how these things work. The last piece I want to explain is how to add resistances in parallel. It's gonna be the most involved part. Once you did that, the good news is we're done with the math for this class. That's what I need to know. And we'll go through the steps, how it's done, how do we add resistances in parallel. So, we have time? No. Okay, I'll stop now. On Wednesday, we'll do resistances in